everyone. Welcome to coding tutorial 11 of neural networks and deep learning. My name is Everly. Today we're going to talk about word embeddings, and we're going to use text classification task as an example in this tutorial. So first of all, our goal is to incorporate word embeddings into a keras model. And also, in this process, we're going to learn about some NLP data sets especially for reference for the upcoming lab assignment. And we will also include some data preprocessing techniques using keras. And then finally, we will implement semantic analogies using the library Jensen. All right, so let's first start with building a model with pre-trained word embedding in keras. And before that, let's start with the data sets. So for the upcoming lab assignment or your final project, um, there are many ways to look for NLP data sets. A very common and easy to use one is Hugging Face. And in this tutorial, we are going to demonstrate how to do that. And for Hugging Face, um, we need to first install this package called datasets. Um, so there are also a lot of other datasets available on platforms such as Kaggle, or you can install NLTK package in from your script. It's similar to what we do with Hugging Face. Um, so there are multiple ways, and if you're looking for a data set, you can always check out these platforms. And if you need further assistance for platforms other than Hugging Face, you can always reach out to me through office hours or you can send me an email. All right, so with Hugging Face, after installing datasets, that's first imported. And for the dataset we're going to use for demonstration today is the emotion dataset. Here's the link. So this is the page of the dataset on Hugging Face. And so to load this dataset, we can just copy its name. And then for this dataset, we will call this package and then load dataset and then paste the name over here. So now we have this data set here. And you can always go to the page and check out what the data set looks like. So for example, the first text data is this. And then the label of it is 0, which is sadness. So there are in total 6 categories in this data set. So you can just check it out. And if you need to look for other data sets, you can always go to data sets here on Hugging Face. And they have a variety of tasks here. You can also find like image related tasks data sets. And we're looking for the NLP dataset text classification. So if you click on this, on the right, you will see a lot of different data sets for your use. So for example, IMDb, this data set is a movie review data set. So for example, this first data is this has this pretty long text, and the label is negative. So this is a binary data set with positive and negative movie reviews. Um, yeah, so basically, this is how Hugging Face works, and I recommend you go through the platform and check out different data sets. Um, and let's go back to our example here. So now that we have loaded the data set, we can get train and validation and test. So, like, how to get all this information and what this data set looks like, you can find all this information in the page of that data set. And so for this one, um, the data is in text and label. So we can first separate the text data and label. Text will be X for input and label will be Y for output. For train, we can have samples. For X in train, we can grab text data, and then for train labels, we can have X label. Again, all this is can be found in the Hugging Face page. And we're going to just do the same thing for validation and test, as you can see here. So we're probably not going to use the test set for this tutorial, but I'm just going to process it anyways. All right, so now with this data ready, let's print out some information to see what the dataset looks like. So first of all, the classes. Let's see if it's indeed 6 categories. We can do unique, the labels here, and we need to import MP. All right, so we can also print out the one example. So let's do example and then the label. So we can just grab the first data from train, and then let's run this cell. All right, so this is indeed the first example that we saw, and the label is 0. So with that, we have this data set grabbed from Hugging Face, and it's ready. So let's proceed to the next step, text data preprocessing. So we have there are many steps for processing text data as taught in class. We're not going to go through all those details here. For example, in coding tutorial 10, we talked about character by character generation, and we did pre-processing such as lowercase, converting everything to lowercase, and then we did one hot encoding with a dictionary of the characters and so on. And for text, for word, so today we're going to work on words instead of characters. And for an easier pre-processing technique, we can just call for keras with the the tool text vectorization. So if you take a look at the documentation here, it says that it converts the string into a list of token indices. So basically, this tool helps us to vectorize the input text data so that we can have a dictionary of text from words to indices. So with that, let's first start from grabbing the importing the okay from Keras layers import text vectorization, and then we can just create a vectorizer here. So for this, we can input some arguments here. First of all, the max token. So let's set maximum to be 10,000. And for output sequence length, that is for limiting the length of the text data, indicating how many words there can be at most. So let's do 100. And with that, we can adapt this vectorizer to our training data. So after doing this, we have the vectorizer and the dictionary ready. So we can grab the vocabulary by get vocabulary. All right, let's run this. So let's print out what's the length of the vocabulary first. And then, so this is the length of the vocabulary because we set the maximum number of tokens to be 10,000. So apparently this train data has over 10,000. We can always try increasing that. And now, okay, so this is the actual total number of vocabularies in there, but we don't need to do that since the occurrence of some words are not that frequent. So let's just do 10,000. And so we can print out the most frequent ones, say the first 10. So these are the most frequently appeared ones in train set, which makes sense, like I, feel, and some stop words. So with that, we can test the vectorizer from inputting a sentence such as I feel good today. And then we can print the the output and the first 4 words. All right. So now when we do vectorizer with an input text string, it will return to us each word's index. For example, the index of I would be 2, which makes sense, checks out here from the first 10 of vocabulary. I is indeed has the index 2, and then feel has the index 3, which checks out too. And then good and today have these indices. So this is what the vectorizer would do for us um, after adapting to the samples. So what we're going to do here is to vectorize all of our data. So we have the actual input data for X train and X validation. So we can call the vectorizer um, for each sentence in string in train samples, we have S and then converted into numpy array. And so this is the data format that we're going to need for inputting to the model. And for validation, we're just going to do the same thing. So let's also process Y. Just simply convert everything to NP array. All right. Now we've got train and validation data ready. So with that, let's move on to the model. So we need to first deal with the word embeddings that we're going to work on. And today we're going to use glove as an example. We can go to the website, and as you can see here, it provides you a link to download their embedding that you can call. And they have the dimension 50, 100, 200, and 300. So with this is basically like a dictionary that we can grab the certain lengths of the vector embeddings for a word. So we're going to first download the embedding, and then with these choices, we are going to use the dimension 100 today. And while it is downloading, we can start with building a dictionary. So let's call this embedding dictionary. So with the file, the text file we have, open this file as F, and then line by line, let's read it. So for each line, we can first split it into the word and the embedding. So let's say word and coefficients. Split the line. And then for the coefficients, convert it by separating from string. All right. So so now we have the both the word and the coefficients ready. We're just going to store all this information into our dictionary. So for this dictionary, when we grab this word, it should return the coefficients, the embedding. So with that, let's print how much words are found. So those are the available words in this embedding that we download. And also the vector length here. So we can have the length of our dictionary, and then let's print out the first the values, and then convert it into strings list, and then oops, the first one, so that should be 100. And all right, so now we have this zip file downloaded and then unzipped it, and the file should be called this if we want 100 for dimension. So let's run this cell. And there are 400 400,000 words found here, and for each vector the length is 100. All right, so with that we can move on to building an embedding matrix for our model. That's going to be for the next step use. So let's create an embedding matrix with the size length of the vocabulary, so that we have all the, for the index in vocabularies, we'll be able to grab the embedding for that word. And then we need 100 here. That's the length right here. And so for each vocabulary, let's iterate the vocabulary we have. If the word is indeed in this dictionary that we have, then we will, for the given index from the vocabulary, we will copy over from the dictionary, get the word. All right, So we can count um, the number of hits because from this dictionary, it's not guaranteed it has all the words that we're looking for. So we just check from this embedding if the number of hits is enough for our use. Convert how many words out of total vocabulary, and that tells us there are some misses, and this will be hit, and then the length of vocabulary, and then the total minus hits, that's the number of misses. All right. So, in total, there are 9,627 words found, and about only 300 misses, so it's not bad for our word dictionary. So let's just work with this embedding. Now we have these embedding metrics here. Uh, we can build an embedding layer. So let's check out Keras. So for Keras, you can call an embedding layer, and what it does is that it turns the integers, which is the indices for the each word, and then turns it into the vector that we have. So in our case, the length of each vector would be 100. And then, so for example, if this sentence has two words, this is basically the input that we've already done through vectorizing. So we can just pass the vectorized data into this layer, and then we will have the length of a matrix with the length of the number of words, and then times the length of each vector, which is 100. All right, so with that, we can import embedding, and for embedding layer, the input dimension would be the length of vocabulary, and the output dimension would be 100, and the embedding initializer would be our matrix, and we should call constant. We can import this from Keras initializers. We can import constant, and we will just throw our matrix into the initializer, and we don't want this to be trainable, so set this false. So for this embedding layer, we're not going to move anything in the existing embedding matrix we have. We just want the model to call the matrix and then grab the existing embeddings from here. So we're just going to set it as not trainable. And with that, now we can finally build a LSTM model. So let's get some layers and model ready. Import the input to in the model. All right. So first of all, we have the index input. Recall that is what we have from calling vectorizer, the data we have. So first of all, the input has the shape that we are not going to specify here. So we leave this as none for each sentence to have the flexibility of length. And although we know that the maximum is 100 because that's what we set for the vectorizer. And then the data type is integer. And then we can throw this input into the embedding layer and then get the embedded data. Embedded would be from this layer. We have this input, and with that we can just quickly build some LSTM layers. And here we're going to use the bidirectional layer of LSTM, and then 20 nodes with return sequences. True. And then here we're just going to pass this, and then we can do another layer of this after this. So now we have two bidirectional LSTM layers, and then we can have the output, and that would be supposed to be the size of 6, and activation function is softmax. So finally we have the model. Oh, forgot to run this cell. All right, so now we have the model ready. With this, I would like to point out here that for this time, you might notice that we didn't use to categorical for Y. That's because we are going to use the sparse categorical cross entropy. I forgot to put the link here. I will add this to the released code. So you can check out its documentation, and basically it spares us from having to do two categorical, but it calculates the similar thing for if we do one hot encoding for the categories, and then calculate cross entropy. So it's basically the same thing. And here we are going to compile the model with this loss, sparse categorical and cross entropy, and that's just easier for our use. The optimizer is Atom, and then the matrix accuracy. So for this model, fit our X train and Y train, batch size 128, epochs, again, let's do 20 epochs. And for validation, X and Y. So, all right, so now the model is training. It's going to take some time, so I'm going to stop the video now and we will resume when the model is done training. All right, and we're back. So the model's done training 20 outputs, and as we can see here, eventually the accuracy got uh, pretty high for both the training set and validation set. It does look like that the model can keep training for a bit, so you can play with the epochs or the model to create a better model and better hyperparameters that gets a higher performance than this one. Um, all right, so with the model done training, we can evaluate a little bit on this model that we trained, although we already have accuracy for both training and validation set. And we can, of course, do model.evaluate on validation set, but it's not necessary now. Um, if you're interested, you can also find the accuracy or other metrics on test set or all this other information. So we're just going to simply perform a prediction and then see how the model does on a random data. So let's say we grab a random um, index from validation, say 100, and then from the validation sample, we can get um, this index and all its data. And for a predict model dot predict, and just input this data, and then we can print the sample and the prediction. Actually, we can just print the prediction. All right. Okay, we should. Okay, so for this data, we have the index from the sample. So if we want to go back to find the original sentence, that should be samples. Okay, so for this sentence, the model prediction is the number 3 category in this data set of emotion. So the above is how we train a text classification model using existing word embedding. And don't forget that for the embedding, we are not updating anything. So we set the trainable as false, and then we just train these following LSTM layers um, based on the embedding and the data set we have. All right, and with that, let's proceed to the last part, semantic analogies. Um, so first of all, we need to install GenSim. So here we are going to perform a very simple word embedding analogy as taught in class. So you can recall this is the analogy we are going to perform using GenSim. Um, so with that, we can first transform the word embedding we have. So basically, GenSim, you can check out their documentation. It's a library for NLP, and they're based on word to vec. So here, since we already have the glove file, so let's use the um, package in GenSim to convert this into a work to vec file so we can work with that. So the original um, file we have is this one from glove, and from GenSim we are going to get this glove to work to vec. And with this, we are able to convert it, and the output file would be the work to vec version, and also a text file. So we can do call this function, and then input would be this, output would be this. So let's let this run for a bit to convert the data. And then the next thing we're going to do is we are going to use keyed vectors to first load the model. And then using the model, we can perform word embedding analogies. So from GenSim models, we can import key vectors. And then let's just load the model we have. Load word to vec format. And then the input would be this file we have. And it's not a binary data. So with this, we can load the model. And then with the model that we have here, because the embedding is already well trained, so basically we can try to perform this inside the embedding to see how it goes. And for example, we can do say king minus man plus woman and see what we get from there. And this would be the first result. Use the model and call most similar. And for here, we can perform the vector operation with the minus and plus. Let's do positive. That would be woman and king. and then the negative would be the -1. So that's man. And just find the first one that's the closest. Um, so we can use most similar to find it. And let's run another example here for Moscow minus Russia and then plus France, and see if this embedding can indeed help us find what we're looking for. And the positive in this example would be France, Moscow, and the negative would be sure. And the first one. All right, now everything is loaded. Let's run this cell. And I forgot to print the results. All right. Okay, so it found the queen as the top one, and of course you can play with this argument too to see what are the other close words in the embedding. And then Paris for the second. That's great. So this is just for you to understand this concept and see that how it actually works in the embedding. And that's all. As a supplementary information here for your reference. Um, if you are looking forward to VAC embedding, you can do the similar thing as we did for glove, where we find this existing embedding in a text file and download it, and then we can just read from there and then create a dictionary and then create embedding matrix, which is the input that we put into constant to the Keras first layer, embedding layer. That's what you can do if you can find different embedding, like where to VAC embedding. And if you're looking for, if you can't find an existing embedding, there's another approach that you can find a pre-trained model and then pass the words into the model. So basically, this is the same thing. If you're looking for the embedding, you can always use the words and then have the model generate the embedding as the output, so that that generated output would be incorporated into your dictionary and the embedding metrics that you need. And again, you can go back to passing it into the embedding layer in your Keras model. And so using this GenSim's load word to VAC format, you can put your path to the embedding here, and then you can grab a dictionary, and then we can just go back to where we start building the matrix and the model. If you have any questions regarding how to run or find embeddings or the text classification data sets, you're welcome to email me. You can come to my office hours or leave your questions on PS. And that's all for today's tutorial. Thank you for watching. See you next time.